Hello, everyone, and welcome. So, we're living in this incredible time where AI is poised to completely change healthcare. We're training these absolutely brilliant AI experts, people who can write perfect code in their sleep. But here's the catch, there's a huge problem. They often struggle to step outside of that world of code and actually talk to the people who need these tools the most, like doctors and nurses. My colleagues and I at Queen's University Belfast saw this major disconnect and decided to build something to fix it.
It's funny. You can have the most powerful AI model in the world, one that could literally save lives, but it often just sits on a digital shelf. Why? Well, it really boils down to one simple word: trust. An AI tool is only as good as a clinician's willingness to use it. And if the developer who built it can't clearly explain why the model is making a certain prediction, that doctor is never going to trust it with a patient's life. It's just not going to happen. So, the core of the issue is this giant gap between the theory that students learn in a classroom and the high stakes, messy reality of a clinic. They've got the technical skills down cold, but they're missing the translation skills. Let's really dig into what this communication problem looks like. Okay, so picture this. On one side, you have the AI expert, deep in the technical weeds. On the other side, you have a doctor who needs a clear, simple, actionable insight right now. And in between them is this chasm, what the researchers call the translation gap. It's a huge bottleneck. Students are trained to analyze, but they just freeze up when they're asked to present.
And look, this isn't just a gut feeling. The team at Queen's University actually surveyed their AI master students before this new module started. And the results were, well, they were staggering. 63%. That's nearly 2 out of every 3 students admitted they were not confident at all in presenting their findings to someone who wasn't a tech expert. What that creates is this whole generation of experts who are completely at home with data, but absolutely terrified of having a conversation about it. They were, and this is a great way to put it, a workforce that was prepared to analyze, but totally paralyzed to present. So the mission became pretty clear. Take that 63% and flip it on its head. So how in the world do you teach something like communication and confidence? Well, I'll tell you one thing. It's not by giving more lectures. The team at Queen's University decided to throw out the old playbook and build a whole new module called AI for Health. The idea was to use gamification and immersive tech to basically force students out of their comfort zones. Now, when I say gamification, I don't just mean playing video games in class. It's actually a really powerful teaching strategy. See, when you frame a tough challenge as a game, students suddenly stop being afraid of making mistakes. Instead, mistakes become opportunities to learn and get better. It naturally gets people to work together, and most importantly, it gives them instant feedback. And you can really see the difference in the approach right here. The standard way of teaching AI is often, you work alone, it's all theoretical, and you're using these clean, perfect toy datasets. The AI for Health model, it's all collaborative, you're using real-world clinical data, and you're getting that instant gamified feedback. The real secret sauce, though, was blending the traditional coding labs with a high-pressure VR simulation that forced them to communicate. The whole thing was packed into 4 incredibly intense weeks. The first 2 weeks were these deep dives, all theory in the morning, and then the entire afternoon was spent in the coding labs, really getting their hands dirty. Week 3 was all about immersing them in real clinical problems. And it all led up to week 4, the final stress test, where they had to put everything they learned into their own individual project. And this is so important. They weren't using some sterile, perfect toy data set. Nope. These students were thrown into the deep end with massive, messy, authentic clinical data, looking at really complex stuff like DNA methylation and gene expression. This made the work feel real. They weren't just moving numbers around. They were learning how to hunt for patterns that could one day help save someone's life. Okay, now for what I think is the coolest part of this entire module. To really put their communication skills to the test, the students were dropped into this high-stress, gamified virtual reality simulation. This is where things got really interesting. The game they used is called Keep Talking and Nobody Explodes. I mean, the name pretty much says it all, right? It's designed from the ground up to be chaotic and high pressure. It's loud, it's stressful, it's fast, and it perfectly mimics the kind of urgent, crystal clear communication you absolutely have to have in a medical emergency. So here's how it works. One student puts on the VR headset, and all they see is a ticking bomb with all these crazy, complex wires and buttons. Their teammates, they have the instruction manual for how to defuse it. But here's the kicker. They can't see the bomb. The only way to win is to talk to each other,
clearly, precisely, and super, super fast. The parallel here is just perfect, isn't it? Think about a surgeon in an operating room, having to communicate with their team under immense pressure. Or an AI expert trying to explain a critical finding to a doctor while a patient is crashing. The game forces that exact same level of urgent, precise communication. There is just no room for misunderstanding when that clock is ticking down. And this stressful game environment does something really amazing. It completely shatters that natural reluctance people have to speak up. It forces them to collaborate and pushes everyone, even students who might struggle with language barriers, to find a way to communicate and work together like a well-oiled machine. Okay, so the whole concept is fantastic, right? A mixed curriculum, real-world data, a VR stress test. It sounds great on paper. But the million-dollar question is, did any of it actually work? Well, let's take a look at the results. The data speaks for itself, and it's incredibly clear. Before the module, only 37% of students felt confident explaining their work to a non-expert. After just 4 weeks, that number jumped all the way to 62%. That's a massive shift. They didn't just become better coders, they became more confident professionals, ready to have those crucial conversations. And what about the students? Did they like it? They loved it. The overall satisfaction rating for the module was a 4.9 out of 5. I mean, come on, that is practically unheard of for a really demanding technical university course. It just proves that this engaging, hands-on style of learning really works. And digging in a little deeper, almost 88% of the students strongly agreed that the module was high quality and well organized. And a lot of them pointed specifically to the VR game, saying it helped them break down communication barriers and connect with their classmates in a whole new way. So, let's zoom out for a second. What are the big picture takeaways from all of this? Why does this one single module at one university matter for the future of AI and healthcare as a whole? Well, what this all means is, first, we've now proven that this communication gap between tech experts and doctors, it can be bridged. Second, we have a brand new framework that other universities can copy, one that balances those hard technical skills with the soft skills that are just as important. And finally, it shows that when you get students actively engaged, they just learn better and are way more prepared for the real world. When it comes right down to it, the bottom line is this: a brilliant algorithm by itself isn't going to save any lives. We have to be able to talk about it clearly and effectively. And this study proves that tools like VR and gamification aren't just fun little extras. They are absolutely essential for training the next generation of healthcare innovators. And that leaves us with a really fascinating question to think about. As our world gets more and more complex, and the need for people from different fields to work together becomes more critical, maybe the best way to train our future experts isn't just in a lecture hall, but inside a game. So in the end, this research gives us a powerful new way to think about education. It shows that sometimes the absolute best way to train an expert is to let them play. If you'd like to learn more about this amazing work, the researcher's contact info is right here. Thanks for tuning in.